Hello and welcome to Minukuu tutorials. Hope you are doing great. In today's tutorial, we're going to look at how to add or create new variables or new columns in R or RStudio. Now, never mind, I'm the type who like details, so if I say add or create, it's basically the same thing. New variables or new columns is the same thing. And in R or RStudio, whichever you are using, whether you are using R or RStudio, okay, it's the same thing. But now, we're going to look at different methods of creating, or if you want, adding new variables or new columns in R. Okay, and some of these methods include using the arithmetic operators like plus, or if you want, addition, subtraction, division, and whatever. And we're going to also look at how to recode variables. Let's say how to recode an existing variable or two or more existing variables to obtain a new variable using the ifelse function or code. Then we're going to also look at how to use the cbind function to create new variables. And finally, I'm going to give you a bonus which you will have to do with renaming a particular column or variable. Now, without much ado, we're going to import our data, or if you want, read our data into R and attach it for us to see how we can create or add new variables or new columns in R or RStudio today. So the data set that I'm going to use is actually the Irish data. Okay, now this particular data set is already in R. For those of you who might have difficulties, sometimes people contact me asking me for the data set that I use. Never mind, even if you need a script that I will be using for this particular tutorial, or the script that I'm going to write for this tutorial, if you need it, simply comment below saying please Minukuu, send me the script. Okay, and then you give me you make sure you put your email address there. I'm going to mail you the script. All right, so without much ado, let's simply import the data set and then see how we can do our addition or creation of new variables or new columns in R or RStudio. So let me first of all show you the data set. Like I said, it's already in R, but I have it in CSV format, so I'll read it into R. And I'll also show you, in case you are watching me and you want something to work on, like you want a sample data set to work on, to practice, I would show you how you can actually get the Irish data set from R itself. It's for free, right? But I have it in Excel format. And for those who don't know how to read data into R properly, especially CSV file into R properly, you would take advantage of this opportunity to also learn that. I'm trying to be as flexible and as simple as possible. We are all learning, right? If I make a mistake, you correct me. All right, without much ado, let's head on to the desktop and then I'll read the data set into R. Okay, so we have our data set here in the form of a CSV file, and to read it into R is very simple. You right click on it and then you click on properties. You click on properties right below, click on properties, and then you click on security, and then you copy the full file path. All right, so let's do that. Now, after copying the full file path, we simply come to R here, and then to read our data set into R, we're going to use any kind of we're going to assign any object to it as our data name. So we're going to name it, for instance, my data. Let me put it this way. My data info. My data is equal to read.csv into brackets, into quotations, then we paste the file path that we copied. So paste it here, then we change this into, either we put 2 backslashes or single forward slashes. for it to work. All right. Okay. Let me create more space. Okay, so I think this is okay, perfect. Now I'm going to show you, like I said, don't worry, I will show you how to obtain this same data set from R without, if you don't have it, or if you want me to send the Excel, or if you want the CSV format to you, I would do that also. So don't worry. So let me quickly run this to read our data set into R. Now it hasn't given us any error, meaning it has read the data without any problem. If I should say print data, print into brackets my data, just for us to see the data set. So here it is. We have the full data set here. Okay, it's a data set of flowers. I don't really know the full history behind that, but like I said, it's a data set that exists in R, so you can read about it, you know. So it's all about flowers. We have the sepal length, the petal length, the whatever petal width, and then the species. So we're gonna see how we can create new variables by recoding and by using all these other methods that I stated earlier on. Okay, so if you want, for instance, we can look at the first 6 rows. If you want the first 6 rows, or is it first 6 rows, then we say head into brackets my data, just to see the first 5, or is it the first 6 rows. Okay, the first 6 rows are here, you know. And now if we want to know how many flowers were there, you know, our sample contains how many flowers, the total number of flowers, or the sample size, then we can just say dim for dimension into brackets my data, and that gives us how many. So it actually contains 150. The sample size is 150 individuals. In other words, or if you want 150 flowers, and there are 5 variables, which means 150 flowers. That's number of rows is 150. Number of columns is what? 5. So as you can see, we have 5 variables here, or columns. This first column of first variable, second has to do with sepal width, third has to do with petal length, fourth has to do with petal width, and then the fifth is the species to which the flower belongs. So there are actually 5 columns, and then in total we have 150 what do we call it, flowers. Now, like I told you, some of you may want this particular data set and you don't know how to obtain it. It's very simple. It's a data set that already exists in R. So to load it, you simply, if you don't have any data, if you want a data set or a similar data set to practice, you simply load your data set by saying Irish. You say data. Just say data. Use the code data into brackets Irish. Now when you say data into brackets Irish and then you run it, okay, your data set is loaded. Now if I should say Irish, if I just write Irish, which means, and when you do this, the name of your data set, anytime you want to write anytime you want to use your data set, just simply, you don't have to assign any object to it. Just write Irish. As soon as you say data into brackets Irish, the Irish data set is already loaded, and anytime you want to use your data set, you simply write Irish. For instance, if I want to show the data set, I just say print into brackets Irish. Okay, and in Irish is the same thing as, you see, it's the same data set. Look at it here. It's the same data set that we have. You see it? So it's the same data set. In case you have difficulties in I mean, you might want to use the same data. I'm saying you might want to use, you might want exactly, you might want to use the same data set. You simply write this particular code that I've entered here. Okay, just say data into brackets Irish, and anytime you want to use in place of mine data, because I read my data from R, so I set mine data in place of mine data, you're gonna use Irish all the time, because this is just a matter of loading in by saying data into brackets Irish in quotations, and then your Irish data set is loaded and you can is ready for use. Now let's move on to attaching the data set. Okay, we've already read the data set, and now we're gonna see how we can attach it. Okay, now to attach the data set, so this particular first step we are already done with it. I don't know why. Let me cut it. I'm so sorry I didn't place it. I started writing above the point, so let me paste it here. I'm so sorry, I wasn't organized at all. Okay, so we have already read and put some space here so everything will be clear. So the first step, like I said, we had to read our data set into R and then attach it. Now to attach your data set, if you have to say, for instance, I have to say attach. Why do we attach the data set? If I want to, for instance, calculate, let's say anytime at all you want to write the name of a particular column in R, for you to write the name of a particular column, you are obliged to write the name of the object which contains the data set. Then you use the dollar operator, and then, or let's say the name of the object, in other words the name of your data set, followed by dollar operator, followed by the column that you want to select. You understand? But if you don't want to use the dollar operator all the times, as well as, you know, if you don't want such a long name, let's assume I want to calculate the mean of, let's say, sepal length. I'm obliged to say mean into brackets mine data dollar sepal length, for instance. So you see that this is too long. Meanwhile, if I had attached, so if I should do this, I have to do this before I can calculate the mean of my my sepal length, right? But if I don't want to do this, if I don't want to write this long thing using my data dollar to select the column or the variable in question, then I could simply attach the data set to. So to attach the data set, you simply say attach into brackets, then you write the name of your data set. In my case, it's my data. Okay, so that anytime I want to write, okay, after doing this, now if I want to calculate the mean of sepal length, I don't have to say mean and then I have to write the name of the data set. Now use the dollar operator to select sepal length. I don't have to waste my time doing this. I simply say mean into brackets sepal length, you know, straight, because I've attached my data set. See that when I started writing, sepal length just popped up. Now I can calculate my sepal length. It gives us the same results. So this is the purpose of attaching the data set. It saves much time and space. Alright, now after attaching our data set, I think we don't have much to do. Okay, one important thing, like I told you, if you are watching me and you want to practice, after saying, let's say, data into brackets Irish to attach your data set, because this data is a pre-existing data set in R, and then after which you said, you know, if you want to also calculate, for instance, the mean of sepal length, you have the choice. You could also say mean. You could also say mean. That's if you attach your data set, the Irish data set, which is the same thing that we are using. You simply say mean the bracket Irish. But first of all, you have to attach. Okay, if you don't want to attach the Irish data set, you simply say mean into brackets Irish dollar sepal length, and you give us also the same result. So anytime you will always have to use Irish as your dataset name. And if you don't want that way, you can also attach your iris. So you say attach to brackets Irish. Sorry, I said Irish. Iris. I'm so sorry. I don't know how I pronounce it. Iris. Okay. So you have to first of all attach your iris dataset. And after attaching it, now if I want to calculate my mean, I could also just simply say mean into brackets sepal length. Okay, and I will not have to write let's say mean to brackets iris dollar sepal length. You see, so in short, attaching the data set helps us saves time and space in writing the name of a particular column or variable. We don't have to write the name of the data set and use a dollar operator to select the variable. It prevents us from doing this. I hope I'm not wasting your time, but I think it's worth it because some people might have difficulties in understanding some of these stuff. Okay, now I think we are done. We've read our data set into R properly. We've attached our data set. Now we're going to move on to the next step, which has to do with what? So the next step has to do with creating our new columns or variables. Okay, so the first method, like I told you, has to do with the use of arithmetic operators such as addition, subtraction, and whatever. Okay, so now mind you, let's just a recap. Let me say header or head into brackets my data, just to show you our data set once again. Here's our data set once again. You see that the data set contains 5 variables or columns. I just showed you the head. If you want the full data set, then we have to say print into brackets data set, and it will show you, it will show us the full data set as I've shown you earlier on. So I think I don't have to repeat. We have this our full data set, but I just want to show you the first 6 rows of our data set, so as to, because this one occupies a lot of space, the full data set occupies a lot of space. So we have 150 flowers, and then we have what, 5 columns of variables. Now the first method has to do with what? Using arithmetic operators such as addition or subtraction. For instance, we may want to what can we do? We may want to, for instance, create a new column or variable that we will call sum of sepal length and then petal length. So we want to create a new variable using an arithmetic operator, addition for that matter. So we want to add the values of what? Sepal length and the values of petal length, which means for flower number 1, we want the value of sepal length plus the value of what? Petal length. So how do we do that? This is very simple. Okay, so, and it's not, like I said, it's what? Arithmetic operators. It could be addition, it could be subtraction, it could be division. Okay, it doesn't matter. So let's start first of all with addition. So let's say, for instance, we want to create a new variable called sum. Okay, so we just say my data. So this method 1, which has to use with the which has to do with the use of arithmetic operators like addition, subtraction, etc. So we say my data, then we use the dollar sign, and then we write the name of our new variable. One thing you should note is that anytime you write the name of your data set followed by the dollar operator, it automatically creates a variable. So if I say dollar, whatever that I write is going to be considered as a new column or variable. So let's say, for instance, my data $sign sum. Okay, so sum of, let's say, sepal and petal length. Sepal and petal length. So sum of sepal and petal length. Okay, let's assume something like it. If I should just run this, okay, after running this, it's telling us null because we haven't yet filled this particular column. However, a new column has been created. So anytime you write anytime you write the name of your data set, and then you put a $sign and put an object and write any object at all, that object would be considered as a variable or a column. A new column has already been created. In our case, a new column has been created, but it has no value, so it's telling us null, right? If you want to verify what I'm telling you, just say head into brackets my data again, sorry, and then you realize that a new column has been added. Sorry, my data dollar. Normally a new column was supposed to have been added. I don't know why. Let me take it again. Okay, I'm so sorry for that. If we want, because it's telling us, you see that it's telling us null because we did not attribute anything. So R will not just add a new header, or a new column with no values, okay, because it's a null. So like there's nothing in it. When I just say my data sum, there's nothing in this particular thing. But let's assume we name it by something. So let's say, for instance, this particular let's say is equal to, let's say it's equal to NA. Okay, so we have to create a new variable, and then we're gonna put all the values of this particular variable would be NA, for instance. Let's do that now. Okay, now let's say, for instance, so anytime you write the name of the object that you have used to denote, let me take it again. Anytime you write the name of the object that contains your data set, in other words, the name of your data set, and then you put a $sign, and then you put any object at all, that particular object becomes a column that will be created. Now if you say it's equal to NA, then it means you want R to fill this particular new column with NA. So let's do that. We have already done that. If I should show you the header of our data set, or if I should say head, you see that there's a new variable that is created called sum of petal and sepal length, and then it's filled with NA. This principle is very, very important. It's just to tell you that anytime you write the name of your data set, and you use the operator, and then you put an object, and then you equate it to something, this particular object here would become a new column, and it will be filled with whatever that you have added. You realize that initially when we did not equate it to anything, and then we set header or head into brackets my data, the column was not added because it's just a space, there's nothing in it. Now, understanding this principle, we're going to apply it to the creation of new variables using the arithmetic operators. Now let's take, for instance, our first example. We're going to say my data, our second example, we're going to say my data $sign, then we say sum of sepal and petal length is equal to, now this time around we're gonna fill it with something else. It will no longer be like the usual business. Okay, so we're gonna say sepal length, then we use plus petal length. okay, which means we are telling R that it should create a new column that will be called sum of sepal and petal length, and then which means, and the values of this particular column will be the addition of what? The sepal length of every flower plus its petal length. That's exactly what we have done. So if I should execute this, if I should execute this or run this, now if I should say head into brackets, you see that our new data set is here. If you want, come over here. If you take 5 plus 5.1 plus 1.4, you're gonna get how much? 6.5 for the first flower. That's exactly what we had here in that order. So it has actually added, it has created a new column which is sum of petal length and sepal length, and it has added what? It has just done that the sepal length plus for each flower. For each flower it takes the sepal length plus the petal length, and that gives us this. We could subtract it. For instance, if we want, we can create a new variable. So if we want to create another variable and we call it, for instance, product, or we could even use product. There's nothing wrong. If we want to use product, then we could say, for instance, we use the bracket sign here to say it should multiply the values of the petal length, the sepal length, by the values of the petal length. This, if you want, we can use division. We can say, for instance, if you want the mean, for instance, let's assume we want the mean. Okay, we want the mean of the sepal length and then the petal length. Then we could change this one to mean. So instead of writing sum, we could repeat it if you want. I don't want to make things complicated. Let's create another variable. Simply, we're going to create another variable, then we call it my data, and this time around we're going to use a dollar sign, and then we will say mean. So mean of sepal length and petal length, sepal and petal length. Then we equate it to what? You open brackets, and then you come and say sepal length plus petal length, then you divide it by 2. So use divided by 2, and it will create us this particular column too. So you see that another column would be created. If I should say, just to show you the head of our data set, the first 6 rows, you realize that a new column has been added. You see it here. Look at the new column. It's here. We have the first 6 columns which are here, and then we have another column here that's added. So if you want, we can even create another column, and we put minus here, and then we say, for instance, difference between sepal and petal length, and then it's just the same thing. So this is how we create a new column using the arithmetic operators. Okay, we could also use, for instance, let's assume, for instance, we could also say my data. Then we create a new variable that we call, for instance, id. Just say id. Okay, then we can equate it to even a vector, and it will still work. So we can equate it to a vector, like we use combination. This is not combination, be very careful. I'm so sorry for that. Concatenation. We're going to concatenate numbers starting from 1 to, let's say, 150. And we're gonna call, it's just like we want to number our flowers. So we just said id, and then we're gonna have number 1 till number 150. There will be a column called this. So you could also just use the my data dollar, the name of your variable, and you equate it to a vector, and you make sure you write your vector very well. It will give you the results. If you want, let's try that. Okay, now if I should show you the head of my data, you realize that there will be another column called id. You see, id has been added. Now, without much ado, we're going to pass on to something else. You could also use minus. For instance, you could have said my data dollar difference between, so the diff SPL, the difference between sepal length and petal length, is equal to, then you say sepal length minus what? Petal length. And also give you another column. If you want, let's try that quickly. So we could say, for instance, my data dollar difference between sepal and petal length is equal to, then we say sepal length minus what? Petal length. And it also gives us another result, length. Okay, don't know why I keep making mistakes, sorry. Okay, so we could also do this. I hope I haven't made any mistake. So there will be a new column that has been created. If I should show you the head of our data set, look at the difference between sepal length and petal length is here. Okay, we are not going to waste so much time on this. It's just, I hope it's clear. It's just a matter of, if you want the product, then you put, instead of in place of this, you put, let's say, brackets to say multiply this by that, and it will still give you the same results. So there's no need repeating and repeating and repeating and repeating. I think everything is clear with regards to creating a new column using arithmetic operators. All right, now we will move on to a different thing. Okay, and that particular method has to do with recoding. Now recoding is also very broad. You know, I could have splitted this particular video into different chapters, or if you want, parts, you know, but I decided to combine everything so that for beginners this would help them and enhance their R skills. You know, we are all learning, so I try to always have you at my heart. Okay, I always have you at heart, so that's why I take my time to explain. Please subscribe to cheer me up, and share with your friend. Like and share. All right, so now let's move on to the second method, which has to do with recoding. Recoding here means that we can recode the values of a particular column to generate a new column. We could say, for instance, for all flowers with, let's say, petal length greater than a particular for instance, greater than the median, for all flowers with petal length greater than the median, consider them as what? Big. And for all flowers with petal length less than the median, consider them as what? Big. As small, sorry. We could just do this recoding. So to do this, we simply say, for instance, we create a particular column that we will call, this column will be called what? We call it size. So we want to know, let's say, the size of the flower. So first of all, our definition for the size of the flower is that for a flower, there's no need writing this. Okay, there's no need writing all these things. We're going to occupy space and time and waste time for nothing. So our definition for a big flower is that the petal length must be greater than the median petal length. Our definition for a small flower is that the petal length must be smaller than must be less than the median petal length. So first of all, we'll calculate the median petal length. So we just simply say median into brackets petal length. So we calculate the median of the petal length. That would give us how much, for instance? That gives us 4.35, right? So the median petal length is 4.35. So now we're gonna say any flower with petal length greater than 4.35 is considered as a big flower. Any flower with petal length less than 4.35 is considered, or the median petal length is considered as a small flower. Now let's do that. So we're going to say, we're going to create a new variable called size. So we're going to say my data, then we use the dollar sign to create our variable size. Okay, is equal to, then we use if else. If else is the condition. So we are going to state a condition. If the petal length is greater than 4.35, consider the flower as a big flower. If it's less, consider it as a small flower. So we say if else, and then we write the test followed by or if you want, we write the condition or the test followed by the outcome. So yes or no, for instance. So we're gonna write, okay, if, for instance, petal length, so you can write petal length is greater than, so you simply use a greater than sign, is greater than, or let's say it's less than, if the petal length is less than 4.35, which is our median, or the median petal length. Now you put comma and write the condition. If the petal length is less than 4.35, consider this flower a big flower, a small flower, sorry. So just write small and make sure you put small in quotations, okay? Since, because it's not a numeric value, so any value which is not numeric, if it's not an object, must be kept in quotations. So you write small. Else, that's why we say if else. Else, consider it as big. And we are done. Now let's run this. So you realize that a new variable will be created called size, and this condition will be applied. Perfect. Now let's look at the head of our data set once more. Oh, I'm so sorry. I don't know why I keep on doing this. We are doing recoding, but I wrote it under the third method, which has to do with using cbind. There's something different. I'm so sorry about that. Let me simply cut it and paste it here at the right place. Okay, so we are over here, we are recoding at this moment. Okay, so now if I should say head into brackets my data once again, just to show you the first 6 variables. Sorry. Okay, watch here. See that a size, the variable size has been created, and all flowers with petal length greater than 4.35 are considered big. If you want, we can let's make it larger than this. Okay, let's say comma, then we say n is equal to, let's say, I'm not sure whether we use n. I want to state, for instance, the first 10. I'm not sure whether this is how the 10 is written. Okay, that's perfect. We are showing the first 10 rows. So you see that there's not still a big flower. Let's say, for instance, the first 20, or we could just, let's leave everything. We could just show everything. Let's say first 30 and see whether there will be a big flower. If there's no big flower among the first 30 flowers, then it means most of the flowers are actually small. There's no still a big flower. That's weird. It means this particular sample has a lot of small flowers. Let's say, for instance, first 50. If there's no still a big flower, then we're gonna change. Let's just print the whole data set. Then let's print the whole data. Let's print the whole data and see my data. And see whether they will be big. Now you see that there are big. The big flowers are very few. Majority of the flowers are small, based on the condition that we have stated, that when a flower has a petal length less than 4.35 is small, and when it's greater than 4.35 is big. So this is a simple condition. Okay, this condition we could have written it otherwise. For example, we could have also written with petal length greater than 4.35. Then we put the first condition is what? Big. It's still the same thing. The second will be what? Small. Else you put small. You know, we can even say, we can write more complex recoding here. For example, you can say if the petal length is greater than 4.35 and you use the end sign, this end. Okay, and for instance, sepal length is equal to, then use, for instance, is exactly equal to, you put double equal to, is equal to, let's say 3.5. Say, then you put a condition, say for instance prematured and matured. So you can change this to matured and prematured, for instance. If you want to say if petal length is equal to this, or then you use this sign, this particular, sorry, the other this sign, you use this to say or. If petal length is equal to this, or sepal length is equal to that, say for instance imported. So we could say for instance imported, if not native. So you can write a lot of conditions. Okay, we're not going to waste a lot of time here. I'm just trying to show you all the possible operators that you can use. So if you want to write your test, you realize that if you want to use or, then use this particular sign here to say or. If petal length is greater than this, or sepal length greater than this, or is equal to, if you want to write equal to, then use double equal, you write double equal signs, press the equal sign twice to say exactly equal to, and then you put the condition here. If you want to say for instance and, if the petal length is greater than this, you write and, for instance, this way, and sepal length is equal to or is less than, then you write less than this way. If you want to say less than or equal to, then you do it this way. So if petal length is equal to 4.3 is greater than 4.35 and sepal length is less than or equal to, this is how you write less than or equal to. If you want to write greater than or equal to, you write it this way, and then you put a condition here. So but in order not to complicate things, this is how, for instance, say big or small, we could run this. For instance, say imported. Let's write this in condition. You can say imported, else native or local. So you see, we can write more complex coding, or we can recode in a more complex way. Now, if I should show you the header of our data set, let me show just the first, let's say the first seven flowers. Okay, so you see that there's a particular, now we're gonna say, instead of saying, let's say size, I don't want the variable size to be created again. So instead of saying size, we're gonna say rather I don't want size because it's not the size, but let's say origin. So the variable is actually called origin, for instance, the origin of the flower. If the petal length is less than 4.35 and the sepal length is greater than or equal to 3.5, then consider the flower as imported, if not local. You know, if you want to say or, then you use this sign. So you are saying that you use this sign if the petal length is greater than this or that, or the sepal length is greater than or equal to 3.5, then it's imported. If not, That's why we say else is local. So you can write as many operations as possible. Okay, now if I just show you the head of our data set once again, you see this is the origin, if we have local or not. Okay, so we can create different kinds of whatever. Let me repeat this and then I'll put a size. So let me just simply copy this code again and paste it, and then I will change the variable. Okay, see that there is an existing variable called size, but because I kept on making mistakes, the variable size is now having, I want to change this. Okay, so I'll change the condition. So I'll say if else, then I'll put size here as is written. So I'll put size here. It'll edit this particular variable size. It'll edit this particular variable here. So I'll say size, and I would say if petal length is greater than 4.35, consider it a big flower. 4.35, consider it a big flower. So I'll put big here. Else, consider it as a small flower. So it will actually change this variable size here for us. Now if I just show you the head of the first 7, you could say first 90, first 20 for instance flowers, and it will print the first 20 flowers for us. So we have the first 20 flowers for instance, and we have the size, small, big, all, first 20 are all small. If we increase it to maybe first 80, or we could just print all the flowers, 150 flowers. And you see that some are actually big, some are small, and this marks the end of this particular second method, which has to do with the recoding. Now let's move on to the third method, which is using what we call the cbind function. The cbind simply means column binding. So it means you can bind a column to your data set. Now this column that you could even bind not just a single column, you could bind a data frame, a vector, whatever to your data set in the form of a column or several columns. Now to do this, we use what we call this code called column bind. It's just another way of creating a data set, a column or a variable. So we could also use the cbind function. Now let me show you quickly how that works. So I could say, for instance, cbind, okay, and then into brackets I simply write the name of my data set of my original data set to which I want to add the new column. So I'll say, for instance, we want to add a data set called what? Let's say our data set originally is my data, right? Now we put comma, then we use I'm just going to write a vector. In the first example, I will write the vector. I will write a vector, okay? So I just write a vector of let's say I'm going to concatenate numbers starting from, let's say, 1 to, no, it's first of all, sorry, I'm so sorry about that. It's first of all important that we create our vector. So let's assume we can create our vector. Let's say number. So just a number. If we write a vector, is equal to, okay, say number is equal to, let's say we concatenate the flower number, right? So say we concatenate what? Numbers starting from 1 to 150. So we have a vector. Okay, if I should show you number, let's see number. So we have numbers, just like how I use, it's the same formula as ID, but now instead of using the dollar sign to create number, we're going to use cbind function. So of using, let's say, my data dollar number is equal to c into brackets, like what we did earlier on here. Let me show you quickly. Like what we did here is the same thing that we're going to do, but this time around, instead of using the dollar operator, we're going to use rather cbind to do it. So to do that, we simply write the number first of all, our vector. It could be a data frame that you want to add several columns, or just a single column. If you are using just a single vector like this, not a data frame, then it means you have to add a single column. Now you want to use cbind, so it says cbind into brackets, you write the name of the original data set, which is what? My data, and we want to add this particular vector to it in the form of a column. So we write, or a variable, so we write what? Num, okay, which is our vector. Now you realize that a new column will be added called num. Let's execute. Perfect. Now watch here. See that the new column has been added called num. And this is also how we can, if you want, we can save the final data set into another object. Okay, so we can say, for instance, my data is equal to, let's say, my data is equal to this particular thing, so that it will save our data set. Or let's say my data 1, for instance, just to differentiate, my data 1 is equal to this original data set, and we have added a new column called num. So if I should say print into brackets my data 1, then we have it here. If I should say head into brackets my data 1, it will show us the first 6. Okay, so you see that we have the first 6 rows, and as you can see, we have a new column or variable called num. So this is another way. And finally, we're going to look at the last way of creating a new variable. It's actually not creating a new variable, because this has nothing to do with using an operator or recoding. It's just a matter of what? Renaming a particular column. So let's assume we want to name the column size. We want to name it flower size. How do we name it? There is a more complex way of doing it, but I'm going to show you a more simpler way of doing it. Okay, I'm going to show you a more simpler way of doing it. There's a more complex way, but I'll show you a very simple way because we have already wasted a lot of time. So finally, to change the name of a particular column, we simply use fix. So you say fix into brackets, you write the name of the data set, which is my data. So if you are, like I told you, you have to use Irish. So anytime you want to write the name, I named my data set by this object called my data right from the beginning. But if you are using the method because you want to practice alongside with me, so you have to always write Irish all the times instead of my data. If you are writing my data, it will give you an error, unless, because I hope you have understood what I'm saying. So make sure if you have loaded the pre-existing data, Irish data in R, then make sure anytime you want to write, instead of, if you are following me, don't write my data, always put Irish all the times. So fix, when you, this particular what is it, this particular function fix helps us present our data set as if it was in Excel format. You see how it is. And now if we want to edit, let's say, let me minimize it. Okay, if we want to edit, let's say, I said which one do we want to edit? Size, right? So size, you want to edit size, you simply double click on size, and then you can edit it here. You can say, for instance, flower size. flower underscore size, flower size, you can change the type of variable. Is it a numeric or a character? In our case, it's character. So it's just done. You simply close it. Now, as soon as I close it, you realize that flowers, where is the variable size, would be changed to flower size automatically. Okay, now we have it here, flower size. There's no enough space, so that's why it's a bit, let me I'm coming. Let me try to enlarge it a bit. I'm coming. Else you can also, let's close this, and if I should print my data again, just print my data again, print my data again. You realize that the name has been edited from size to flower size. Sorry, look at it here. It used to be size, now it's what? Flower size. Thank you so much for watching, and this marks the end of our tutorial on how to create new columns or variables in R or RStudio. Please subscribe and share with your friend.